The next example involves a sag curve. Check how the elements are solved here in engineering surveys. The curve is made from a back tangent of negative 4.2% with an ascending tangent of 3% grade. The PVI is located at station 10 plus 020 with an elevation of 100 meters. It is also stated that the length of the whole parabolic curve is 260 meters. The first question is the distance of the lowest point from PVC, followed by the vertical offset of the curve to PVI. Next is the elevation of the lowest point on the curve, and then the elevation of the invert if a 1 meter diameter culvert is placed at the lowest point of the curve. Let's illustrate the curve again. The first tangent is descending at a grade of 4.2%. Then the forward tangent goes up by 3%. Apart from this data, the details of PVI were also provided, stating that its elevation is 100 meters, and it is stationed at 10 plus 020. One of the tasks is to look for the lowest point. This is shown at this location, but we are going to validate this later in the computation. The whole length of the curve is 260, which means that the distance from PVC to PVI is 130, which is also the same from the intersection to PVT. First is to verify the location of the lowest point from PVC. This can be computed using the grade diagram. So let's illustrate this first. From PVC, the grade goes downward at 4.2. Then, this connects way up to PVT with positive 3. The inflection point locates the lower point of the curve, marked as W. We take similar triangles to solve for the distance we are looking for. Start with the small triangle with S1. The ratio is S1 is to G1. Then, the bigger triangle has the ratio of L is to the summation of the gradients. Plug the values from the illustration and get S1 is to 0.042, and this is equal to 260 over 0.042 plus 0.03. S1 is then simplified as 151.6667 meters. The next task is to identify the vertical offset of the point of intersection to the curve. This is simply looking for h. And since we already have a derived function for this, which is an 8 of L with the difference of the gradients, we only need to plug the figures. That's an 8 of 260 multiplied by negative 0.042 less 0.03, where h comes out to be 2.34 meters. The third requirement is the elevation of the lowest point of the curve. We have already identified from the first task that the location of the lowest point is 151 meters away from PVC. And since more details were given on PVI, take the gap between these 2 points and label that distance as x. X is then solved as S1 less half of L, which is then 151.6667 minus 130, and x comes to be 21.6667 meters. We've identified the horizontal location from PVI, so what's next? From PVI, we trace the point just below point W from the tangent. We call this point Q. Then take the vertical offset y to reach point W. We refer everything from PVI because it is only PVI with elevation and station. Using the definition of the gradient, As rise over run, we can take the height of point Q as a gradient of 3% times x, which is 21.6667, and this gives x of 0.65 meters. Now we take the elevation of point Q using the elevation of PVI, which is 100 meters. Then add the height of 0.65 to get the elevation of point Q as 100.65 meters. After reaching point Q, all we needed to do is to take the vertical offset of this point to reach point W. We have the function of y as 4h with the square of x upon L squared. We have just computed h from the previous requirement and got 2.34 meters. But in this case, since the lowest point is at the right half of the curve, x will have to use S2 instead of S1. We need to solve S2 then, and it is simply the whole length less S1. That is 260 minus 151.6667, giving 108.3333. Place these two figures into y and get 4 of 2.34 with the square of 108.3333 over 260 squared. Y is computed as 1.625. With y already known, we then determine the elevation from Q, which is 100.65 meters. Add y of 1.625 to have the elevation of point W as 102.275 meters. The last task is to determine the depth of excavation in case a 1 meter diameter culvert is to be placed at the lowest point. The problem states that the culvert should be buried about 0.6 meters beneath the surface. Knowing the elevation of the lowest point, all we needed to do now is to subtract the subgrade depth of 0.6 meters, then also the 1 meter diameter of the culvert. The elevation of the invert is then determined as 100.675 meters.